All right, good morning, students. So, I'm making this video for my second example just in case things get a little bit too much. So it says, now let's consider the expression 2x or 2 times x plus 5 and 2 times the quantity x plus 5. Use the table to evaluate each expression for different values of the variable. Complete the table of values for each value of x. So let's begin. X equals 0, 2, 4, and 5. So let's do that for the first one. So I'm going to do that over here. So 2 times 0, because remember, this is practicing the art of substitution, where you replace the variable with a known number, plus 5. 2 times 0 is 0, plus 5 is 5. Next, we have 2 times 2 plus 5. 2 times 2 is 4, plus 5 is 9. Then we have 2 times 4 plus 5. 2 times 4 is 8, plus 5 is 13. And then 2 times 5 plus 5. 2 times 5 is 10, plus 5 is 15. Now let's do the other expression. So 2 times the quantity 0 plus 5. So parentheses first. So 0 plus 5 is 5 times 2 is 10. Then we have 2 times the quantity 2 plus 5. 2 plus 5 is 7 times 2 is 14. 2 times the quantity of 4 plus 5. So 4 plus 5 is 9 times 2 is 18. And then we have 2 times the quantity of 5 plus 5. So 5 plus 5 is 10 times 2 is 20. What can you determine based on the values in the table? These expressions are not equivalent. Use the distributive property to rewrite the second expression, which is this one. So we have 2 times the quantity of x plus 5. Remember, distribute to give through multiplication, or it could be division, in this case, multiplication. So 2 times x equals 2x, and then 2 times 5, keeping my operation, is 10. So it is 2x plus 10. This is why they're not equivalent. Are the two expressions equivalent? Explain your reasoning. They are not equivalent because when using the same value for x, the answers were different. So they're not equivalent because when using the same value for x, the answers were different. All right, let's go to the next page. Last but not least is number 8 for this one. So we're on page 648 or 734. So it says use the table of values to sketch the graph of both expressions on the coordinate plane. Plot the values for each expression on the coordinate plane. Use square to represent the values from the first expression and a triangle to represent the values from the second expression. Then connect the results for each expression with a line. So for our first expression, we had 0 and 5. So at 0, we were at 5. I already know each line is worth 1 because we went from 0 to 2 with a line in the middle. So 0, 1, 2, 3, 4, 5. Next was 2 and 9. So 9 is in between 10 and 8. Then we have 4 and 13, which is in between 14 and 12. And then we had 5 and 15, which is in between 16 and 14. Now that's my first expression. Second expression, we had 0 and 10. Then we had 2 and 14. Then we had 4 and 9. No, 4 and 18. 4 and 18.
Good morning, teachers and staff. Good morning.
So that was 4 and 18. And then the last one is 5 and 20. So 5 is the next line over. 5 and 20. And then I connect those. Now, what does the graph tell you about the equivalency of the two expressions? They are not equivalent because they create two different lines. If they were equivalent, they would make the same line. All right, the next two are going to be separated by rows. So that's what we're going to do next. So please listen for the instruction. Bye.